Tonight's Enviro Cafe is a part of a long history of events and speakers that has sponsored, focusing on one aspect or another of the intersection between shoreline health and lake water quality. Tonight's speaker is Katie Paroschy, and as Susan mentioned, she's a member of the Environment Halliburton Board and a founding partner with Zygoptera. Zygoptera. I practiced this for about 10 minutes earlier. Zygoptera, an environmental consulting firm located in Halliburton County, Muskoka, and the District of Parry Sound, where Katie works as a project manager and a biologist. Katie's presentation tonight is entitled My Shoreline, Our Lake, and focuses on the complexity of preserving our lakes by bringing the science from some of EA's past presentations together, including a presentation by Liz Favat, Neil Hutchinson, Brendan Martin, Norman Yan, Cindy Chu, and Paul Heaven. Katie has a Bachelor of Environmental Science degree from Trent University and a master's degree in Resource and Environmental Management from Dalhousie. She's worked for governmental organizations, including a number of municipalities, the Ministry of Natural Resources and Forestry, the Ministry of the Environment, Conservation and Parks, and the Canadian Forest Service. Most recently, Katie has started an environmental consulting firm with two of her colleagues, and I'm not going to try to pronounce the name again. Katie lives in Halliburton, where she enjoys cross-country skiing, fishing, and tending the vegetable garden with her husband and young son. So please join with me in giving a warm Halliburton welcome to Katie Paroschy.
Thank you. Okay, I'm going to share my screen here. Hopefully it works. There we go. There we go. Can everybody see that?
There we go.
Good. Okay, so let's get started here. Thank you so much, Susan and Terry, and thank you all so much for attending tonight. I hope this presentation acts or is part of a launching pad for your educational journey, and you take something away from it, specifically how you can help your local watershed, lake, or river. Though I have lots of education, I want you to know I'm not a scientist. I'm just someone who's really interested in this kind of stuff, and I want to pass on positive change. So I hope that you can do the same. During the question and answer period, like Terry indicated, I will have two wonderful young scientists, Carmen and Liz, so they'll be able to answer any of your really difficult sciencey questions that you might have. Okay. So I'm going to start with the big picture and work my way down to the nitty gritty. So what, by nitty gritty, I mean the stressors on our lakes. So there are many stressors. I'm only going to be touching on a few. And now if you're unclear as to what I mean by stressor, think of it like this. What stresses you out? Perhaps it's your partner, perhaps it's your kids being in the back of the car. Perhaps it's your job or getting your taxes done on time. We all have stresses. And now when this stress builds up, what happens to you? You don't feel good and you become ill. So the same is for lakes. When they're under stress, they become ill. So I'm also going to attempt to make some connections between our stressors and suggest ways that you, as a watershed resident, can help. So before I get to the presentation, I think it's important to note that we all come from different backgrounds. We all have different perspectives and different beliefs, but I think we can all agree on one thing, and that's that the earth is necessary. We can't survive without the earth. So with that in mind, I'm going to read a small part of the Haudenosaunee Thanksgiving address, which focuses on water. And from what I understand, this is given before meetings, before school starts, and before presentations. And this just reminds all the attendees as to why we're here. Now, if you want to learn more about the Haudenosaunee Thanksgiving address, I suggest reading this book here. It's called Braiding Sweetgrass by Robin Wall Kilmer, and it's a really excellent book. Okay, so I'm just going to read a small part of it here. We give thanks to all of the waters of the world, for quenching our thirst, for providing strength and nurturing life for all beings. We know its power in many forms: waterfalls and rain, mists and streams, rivers and oceans, snow and ice. We are grateful that the waters are still here and meeting their responsibility to the rest of creation. Can we agree that water is important to our lives and bring our minds together as one to send greetings and thanks to the water? Now our minds are one. So together, let's learn about water and give thanks to it. We want to keep our waters beautiful. So also, as Terry mentioned, Environment Halliburton has brought in many amazing speakers over the last couple of years, and specifically some of the last most recent talks. And these people talked about watershed, fresh water, and environmental health in general. So the objective of my presentation is to bring some of these things that they talked about together and make those connections, and just emphasize that these stressors create a multifaceted problem for our lakes. And I also want to give you the enthusiasm to continue to learn. So if one or more of these topics really interest you, you can further your educational journey. But I think the key message that I want to really emphasize is what we do on land impacts our water. So I'm going to start with the big picture, like I said. So we're going to look at the water cycle. So as you know, water moves constantly through the earth, and it actually does so quite quickly. And as it moves, it brings things with it. It brings soil and chemicals, nutrients, garbage, rocks, and much more. So you can see here just how it kind of goes around in a circle, but it's always moving and is in different forms. Water is simply amazing, and we all need it to live. So the water cycle transports water from watershed to watershed. So we have the water cycle, which is the big picture. And then on Earth, we have watersheds, and you can have a big watershed or you could have sub-watersheds. And actually each lake has its own watershed. So the water cycle transports water from watershed to watershed, and the watershed consists of a portion of the water cycle that happens within a specific land area, as you can kind of see here. So I hope you can all see that there. And the watershed is a geographic area bounded by elevation divide, causing the water to drain into a particular water course or river or water body. So here you can see the high hills, and the water drains down into this lake. So as an example, here in Halliburton, we have the Gull River and the Gull River watershed. So everything that happens around the Gull River goes into that river and continues to flow downstream actually into Balsam Lake. So within a watershed, we have many different things. And this includes land, water, plants and animals, and man-made things like buildings, farms, infrastructure, cars, machines, sand pits, and playgrounds. Everything you can see or touch has potential to negatively or positively impact your watershed and the water within it. So within watersheds, we have, of course, lakes. So lakes is often what we relate to when we're thinking about our fresh water. This is particularly true in Muskoka and Halliburton, where we have our iconic lakes. Our lakes is what makes us want to live, visit, work, and play here. So, and simply defined, a lake is a large body of water surrounded by land. And in a lake, we find many different things other than water. We find nutrients, minerals, plants, fish, amphibians, mammals, insects, sediment, rocks, and unfortunately garbage. So my presentation is going to focus on, like I said, some of the things that stress lakes. I also want to point out that there are three main types of lakes: oligotrophic, mesotrophic, and eutrophic lakes. In Muskoka and Halliburton, in this part of Ontario, we have mostly oligotrophic and mesotrophic lakes, which means that they're low nutrient lakes. You don't have a lot of growth like you might see if you were to travel further south. Now, as my presentation is going to be talking a little bit about science and scientists, and I'm talking about some of the past scientists that have presented, I think we need to answer the question as to what and how is science done on fresh water. So, of course, limnology is the study of lakes, but this is not the only piece of the puzzle. There's also hydrology, which is the study of water movement, ecology, which is a study of organisms and their relationships to each other, as well as their surroundings, chemistry, which is the study of chemicals, and biology, which is the study of living organisms. So scientists looking at lakes do so in many different ways. For example, they may carry out fieldwork and monitor and measure what is already happening there. So an example of this was if you attended last month's Enviro Cafe when Brendan Martin from ULinks talked about monitoring benthic invertebrates. So he's just going out and sampling what's there and doing it over time to get an understanding of the lake's conditions. And as you can see, that's also what I'm doing here in this picture. I'm just making notes of what's happening in the environment that I'm looking at. Another one is manipulating the environment. So up here in this picture, this was from the Experimental Lakes area, which is located in Northern Ontario. So Dr. Schindler and others in the 1970s put chemicals on one side of the lake, put a barrier here, and put chemicals in this part, or sorry, nutrients. And what they noticed is when the phosphorus was added, the algae grew. Without adding phosphorus, there was no change in the algae. So that's manipulating the whole environment. Also, laboratory work is a huge part of how lake science is done. So down here, we have some mini lakes. So these little mini lakes have water fleas or zooplankton in them, and different things are added to them. So perhaps one may add salt or different chemicals and see what happened to the zooplankton. And that's to resemble the real world lake up here. Many scientists will also review, repeat, or compile information that other scientists have done. So if there's long-term data sets, that information can be analyzed in different ways and looking for new things. So I think Carmen, who is on the panel, for example, this is something that she's doing. Most studies involve combination of many of these methods. So you can tell from this that I am an amazing artist, and I just drew this beautiful picture to bring together all our different lake stressors that we have. So no matter where we are, whether you're in a forest, a city, a yard, or a boat, we're all in a watershed, and our actions can negatively or positively influence what we're doing in that watershed. So I've just picked a few of the stressors that we're going to talk about today, and I drew them. So here I have salt or sodium chloride, and this is illustrated by the snowplow spreading salt. Obviously, this would actually be done in the winter along a road. And I'm also going to talk about calcium decline, which is illustrated here by deforestation and acid rain. I'm also going to talk about endocrine disrupting compounds. So those are down here. And that's illustrated coming out of the tile bed of the septic tank, as well as by this individual spraying some herbicides. I'm going to talk about nutrient loading. So this person's spreading fertilizer here. So they have potassium, phosphorus, and nitrogen that they're spreading. And it's also illustrated here where soil has eroded into the lake, and that soil contains nutrients. I'm also going to talk about wetland loss, which is illustrated here by the bulldozer pushing dirt over the wetland. But as you know, wetlands can also be lost when their inflows are diverted. I'm also going to talk about climate change, which is illustrated by industry, but GHGs come from many different sources. So now I'm going to go through the stressors and how they impact our lakes and provide some suggestions on how you can help. So let's first talk about salt, otherwise known as sodium chloride pollution. So according to Reed et al., road salt is one of the greatest threats to fresh water around the world. And there's many different things that increase salinity in our water. So this can be from agricultural practices to resource extractions. And in some parts of the world, there's actually naturally occurring salt deposits, but there's none here. So in Canada, the main cause of salinity in lakes and rivers is from de-icers. So that's spreading salt on our roads, sidewalks, and parking lots. So salt is very soluble and it travels easily into the ground and surface water. And as concluded by Todd and Kaltnecker, more roads means more salt in our lakes. Makes sense. So why do we care about salt getting into our lakes? Well, at various concentrations, salt is actually toxic. As you may know, if you have too much salt, it can be bad for you. Well, it's the same for the natural environment. It's toxic to many, many animals, and even actually in the GTA, it's been reported to threaten drinking water. And this was in a report from 2020 by Dr. Yan. So to make matters even more complicated, lakes in Haliburton and Muskoka are especially vulnerable to the toxic effects of salt. In 2018, Brown and Yan determined that sodium chloride and calcium chloride at low levels are toxic to native water fleet. So you can see here's a zooplankton or Daphnia, otherwise known as a water flea. And these are particularly sensitive to salt. And even more so in lakes that are not very productive. So like I mentioned before, the two types of low productive lakes, the oligotrophic and the mesotrophic lakes, they don't have a lot of growth, like they don't have a lot of algae, and water fleas or Daphnia eat the algae. So if you think of it this way, you are more prone to illness when you are underfed. So these little guys are being underfed, and then someone dumps a whole bunch of salt on them. So they're more likely to become ill or die. And if you didn't know this already, Daphnia are an essential part of our aquatic food web. So they eat algae and are also food themselves for many, many animals. Without Daphnia, there'd be no fish. So a proposed theory is that increased salt in lakes increases the opportunity of algae blooms. So as salt increases, Daphnia decrease, and therefore we have more algae. This plus nutrients and temperature increases due to climate change can increase our algae blooms. Now, a really interesting study that just came out in 2020 by Arnott et al. Says that, well, first I'll tell you what they did. They tested the effects of low calcium on the toxicity of salt to native Daphnia. So now we're talking about calcium and salt. And what Arnott and her fellow scientists found was that salt was toxic to a few species at levels as low as 5 milligrams per liter. To put this in context, the Canadian guideline for salt concentration is 120 milligrams per liter. Furthermore, they found that salt was toxic to 6 Daphnia species at 40 milligrams per liter, which again is very low. And this is in lakes typical of Muskoka and Haliburton. So this means that at low calcium is a contributing stress or threat to the survival of our entire lakes. So we're actually going to talk a little bit about calcium next. First, I want to just give a little illustration. So here I have a liter of water. And here I have 5 milliliters of salt, or very little salt. You can't even, it's like a little sprinkle. And if I put it in there, that is enough to unfortunately kill Daphnia species. Doesn't take very much at all. So let's talk about how you can help this situation. Well, the first thing you can do is encourage your municipality to develop a salt monitoring plan. So my understanding is that actually District of Muskoka has one and Haliburton is working on one. I also encourage you to encourage others to continuing monitoring and research. And there's some great organizations and universities out there doing that. And of course, be aware of your salt use and consider alternatives. Find a balance between de-icers and the environment. Alternatives include sand or wood ash. Okay, so now we're going to talk a little bit about calcium, which as we learned is connected to salt. Oh yeah, that's to show how little salt it takes to make a big difference in our lakes. So calcium is the Tums of the environment. So here we have some Tums, and Tums, or calcium, help stop environment from becoming too acidic, just like they help you from acid reflux. Calcium is a natural occurring element found in rock, specifically limestone. And but here, of course, we have very little limestone. So those, in some parts of the world who do have limestone, please don't take it for granted. Now, historic acid rain in the 1970s, 1980s, along with logging practices, resulted in much of our watersheds being stripped of calcium. So calcium levels have fallen actually between 20 and 40% over the last 4 decades. That's pretty significant. So why do we care about calcium in our lakes? Why do we care about Tums? Well, like us, who get calcium from our food and water, aquatic animals need calcium to survive. It's needed for bone strength and for those animals who have shells like crayfish, snails, and of course the little Daphnia that we already looked at. So it's needed to build and maintain these bodies. And Daphnia, like I already mentioned before, are zooplankton that are the basis of our aquatic food web. So in lakes with very low calcium, you may not find many of these animals. For example, I know when doing some studying with the MECP, some lakes had no snails because they were so low in calcium. One study I found indicated that lakes with low pH levels, 4.5, and calcium levels below 0.8 milligrams per liter will be fishless. So if you think about this, calcium in our area lakes are already low at 1.5 milligrams per liter. And the pH in our lakes ranges from 4.9 to 8. So we're really on the edge. And if our lakes lost fish, what would that mean for our communities? And what would that mean for our local economies? Now, to me, this is a really important issue as we are on the brink of lake collapse potentially. So we need to know how you can help. And actually, it's pretty easy. You can help by donating your wood ash. There's a program in Muskoka ran by Friends of Muskoka Watershed called Ash Muskoka. You can just Google it. You can donate your wood ash to them. And they're doing some groundbreaking research on the effects of calcium in wood ash in our local forests. If you don't want to do that, you can also just spread it on your own forest. Please make sure it's your own property and not any burned garbage, just wood. So you can support these groups and other universities that are doing this research. And another thing you can do is just leave as much vegetation as possible on the land. So even if you're removing trees or other things from your property, leave the down branches like I've shown here, so the calcium can return to the soil. Okay, we're going to switch gears quite a bit now here. So the last two I was talking about were connected. This one's a little bit different. I'm going to now talk about endocrine disrupting compounds, which is another stressor for lakes. EDCs is the short form. So EDCs interfere with hormonal activities of the body's endocrine system, so resulting in adverse effects for wildlife and humans. So EDCs are synthetic chemicals found in many everyday products like this. So pharmaceuticals, specifically hormones, anti-inflammatories, antibiotics, lipid regulators. They're also found in personal care products. Like here, I got some Dove facial cleanser. They're also found in plastics, flame retardants, heavy metals, and pesticides. So I'm showing here. So some examples that you may have heard of are BPA, which is found in plastic. Now it's often replaced with BPH. But the effects of BPH, I think, aren't fully understood. And some papers even suggest that they're worse or the same as BPA. Another one is DDT, which is an insecticide, no longer used in Canada, but still used in other parts of the world. Also phytoestrogens. Phytoestrogens, they are naturally occurring and they're found in food like soy. So EDCs are introduced into our waterways by going directly down the drain or in our urine and feces. They can also be buried or applied directly to the land. So if you think about a garbage dump and all the plastic that's in there, that's just full of EDCs. These substances can result in effects like feminization of fish and tadpoles, population crashes of filter feeders like mussels, as well as fertility issues and cancers for many organisms. Current wastewater treatment technologies have a widely varying capability to eliminate EDCs, meaning that many of these compounds do make their way to our surface water. So how can you help? That's the next question. Well, again, there's some pretty easy things that you can do on a daily basis. Start by never dumping your medications down the drain or toilet. Bring them to your local pharmacy where they can be disposed of properly. I also recommend, instead of using things like this, use some plant-based products or make your own. You can also lobby the provincial municipal governments to implement monitoring programs and upgrade their sewage treatment plants. And of course, you can keep your septic tank in good working order. You don't want to have any overflows. All right, so that's the end of EDCs there. And if you want to find some more information on EDCs, I recommend that you look up on the Muskoka Watershed Council website. They do have a good report that was written in 2017 that sums up a lot of this information about EDCs, specifically to our area. So now a little bit related, because it can come from the same source, is nutrient loading. So I feel like this is going to be review for a lot of people, but it's a big stressor on lakes, so we got to talk about it. So nutrients are chemical elements that naturally occur in the environment. So they come from rock and soils, and nutrients are essential to life. But just like anything, if there can be too much of a good thing. And therefore, we have some nutrients that are of big concern for aquatic environments, and specifically nitrogen and more so phosphorus. So with excess nutrients and the right conditions, so warm weather, low wind, etc., algae and aquatic plants can continue to grow and grow and grow in excess. Just like if you over fertilize your flower bed, you'll have a lot of flowers and probably a lot of weeds. So when these plants and algae die, the microorganisms in the water break them down, and those microorganisms use dissolved oxygen. Dissolved oxygen is simply oxygen that's been mixed in with the water, so it's dissolved into the water. And the microorganisms use this oxygen. And when they use it, that means that other organisms like fish don't have any oxygen. So the fish in turn die. Excess nutrients enter our surface water from fertilizer applications, sewage treatment plants, household products, personal care products, and a big one is soil erosion. So how can you help? Well, again, you can help by using plant-based household products, natural products, minimize or stop using your fertilizer. You can also participate in the Ontario Lake Partner Monitoring Program. So if you live on a lake, you can go out and take water samples, and then they are assessed in the Dorset Environmental Science Center laboratory, and they can tell you what your phosphorus and other levels of nutrients are in your water and whether they're increasing or decreasing. You can also encourage your municipalities to minimize their overflow with sewage plants. Municipalities should be anticipating big rain events with climate change and figure out ways to minimize this overflow. Also, of course, just like with EDCs, keep your septic system in good working order. And I also recommend that you know where your food is growing, and if possible, grow your own. So here I have my little tomato plant. And what's good about growing your own vegetables is that you know what you're putting on them and in them, and therefore you know what you're putting in your watershed and what's going to make its way to your surface water nearby. So speaking about plants and vegetations, let's talk about another stressor on lakes, which is vegetation removal. So I want you to plant your vegetation to grow and eat, but sometimes people remove vegetation as well. And this can have big effects. So with vegetation removal, I suggest all vegetation is important in a watershed. So whether it's trees, shrubs, annuals, perennials, whatever, all native natural vegetation is essential to help protect the quality of our water. So Schindler and Sherrill in 2002 stated that a local ecosystem is driven by inputs of nutrients and energy from far away or adjacent habitats. So cumulative and landscape studies suggest that pristine lakes have a majority of natural vegetation intact. So no matter where you are in your watershed, all vegetation is important because it does so much for us. And removing large amounts of vegetation has localized and whole watershed impacts. And like Schindler and Sherrill talked about, groundwater, rivers, lakes, ponds, and wetlands are habitat networks. So everything is connected. And when you're removing large swaths of vegetation up a wetland, that's affecting the groundwater as well as the nearby lakes. So vegetation in our watersheds is really important because in the warm months, vegetation absorbs nutrients and plants keep things, including us, cool and moist. While in the cold months, the vegetation provides essential habitat for all animals and protects us from heavy snow and strong winds. Vegetation helps mitigate the impacts of climate change in many different ways, whether it's from absorbing or holding on to GHGs, from, like I already mentioned, mitigating the strong winds and effects of big storms. Like I talked about previously, calcium is in decline, and when you remove trees, like they did in the past with all those logging practices, they remove calcium and other minerals from the watershed. Buffer strips, so vegetative buffer strips specifically along surface water, can mitigate the effects of agriculture and forestry activities by acting as a physical barrier to stopping sediment and nutrients and EDCs from being carried into our streams and surface water. So how can you help? Well, no matter where you are in the watershed, so whether you're way up here away from the lake, or whether you're way down here right by the lake, instead of clearing your lawn like these people have done, or cutting down all the trees like up here, you could just leave your vegetation. Just think, what would this area look like without human intervention? Remember, nature knows best. And if something is disturbed, like either one of those areas, you can help by just planting vegetation. Now, currently we're in a time when we can't hug the people we care about. But you know what? You can hug a tree. Or like in this picture up here, if the tree's too small to hug, you can give it a kiss. So get outside and thank a plant because we wouldn't exist without them. Now we're going to talk about somewhere that has hundreds and thousands of amazing, beautiful, different species of plants. We're going to talk about wetlands and the loss of our wetlands, which I talked about before as being illustrated by the bulldozer filling in this wetland. So a wetland is simply that. It's wet land. It's an area that has standing water at or near the surface for most of the year, though it doesn't have to be continuously wet. So wetlands may be located along shorelines, rivers, banks, but are often found in isolated depressions, kind of like what I had in my picture. And they can be huge, or they can also just be really small. So why are wetlands important? Why do we care? Well, I suggest you watch season 4, episode 5 of the Magic School Bus. So the council in Walkerville is trying to decide if a mall should be built over a wetland, and Miss Frizzle's class is asked to debate the issue. So here's the council here, and Carlos here is giving a demonstration. So the council, the council in Walkerville is trying to decide if a mall should be built over a wetland, and Mrs. Frizzle's class is asked to debate the issue. So at first, the class is really in support of the mall because who doesn't like shopping? And wetlands are smelly and useless, right? Well, under the guidance of Miss Frizzle, Liz, and the bus, the class quickly learns that wetland clean water by holding and filtering oil and other contaminants like fertilizers and pesticides. They also learned that the wetland provides habitat for thousands of animals, like really cool wood ducks, hawks, frogs, turtles, mosquitoes, and muskrats for either a part of or their entire life cycle. And wetlands also help to mitigate the increases of atmospheric carbon as a result of climate change. So, but most importantly, during a heavy rainfall, which can be related to spring freshet like we have around here, the class learns that the wetlands hold water. They control the water levels and stop the town from flooding. So after learning this, the students change their minds and decide that they want to preserve the wetland. Miss Frizzle concludes that the wetland is the best land, and her students convince the council that the mall should be built in another location. Now, if you think about it, Walkerville could really be any town, and it could most definitely be my town. Now, Paul Heaven presented at Environment Halliburton Enviro Cafe to a packed room. This was before COVID-19, and he discussed the importance of wetlands, as well as the work he and the Halliburton Highlands Nature Trust have been doing regarding wetland mapping in Halliburton County. Now, with Southern Ontario having lost 56% of our wetlands since settlement, the mapping of wetlands is extremely important. If wetlands are not correctly mapped, then those who are working in government, so those who issue building permits, those who are in planning, those who are in conservation, enforcement, etc., have a very difficult time controlling development. So when you see a bulldozer like this, pushing fill over cattails, frogs, and sundew plants, in most cases, the property owner has actually been granted permission to do so, or the action cannot be stopped because the land is not recognized politically as a wetland. So how can you help? Well, obviously, the first thing is to encourage our governments to complete detailed mapping and develop strong wetland wetland legislation. We have to really know what's out there and have it properly mapped. We also need to provide comments to our governments on projects that impact our wetlands. There are some planning tools that exist to stop development if you think it may be, if it's over a wetland, but that wetland may not be correctly mapped. Of course, you need to preserve wetlands on your own property. And I really strongly encourage you to get out there, explore wetlands, and then share your knowledge. Because once you learn how awesome they are and how many cool things are in wetlands, you'd never want to see them be destroyed. All right, so that's wetlands. And also, if you want to know, you can find this episode of Magic School Bus on Netflix as well as on YouTube. So we're going to go to the more encompassing stressor of climate change. So climate change is, of course, a huge stressor, and it actually makes everything worse. Climate change is the multiplier, if you will. So in 2005, Chu et al. Say that the climate change scenario projections for Canada suggest that by 2050, temperatures will increase by about 4.9 degrees Celsius. So this temperature rise may not seem like a lot to you, just 4.9, but it will result in changes to our local weather and climate conditions. So these include different precipitation volumes and patterns, release of other things too, like carbon dioxide, sulfur dioxide, nitrous oxides. And all of these things will impact the ecological processes in direct and indirect complex ways. And specific to lakes and rivers, climate change has already led to and will continue to cause increased water temperatures, decreased dissolved oxygen concentrations, which I already mentioned as being essential to fish survival, as well as altered water chemistry and chemical loads. In certain regions, it will also create new water quality challenges, including increased dissolved organic carbon and toxic metal loads. So that means there'll be more toxic metal in the water. Example would be mercury. So climate change, like I mentioned before, makes all these things worse. It's the multiplier. So let's bring some of these previous stressors I talked about and show how they can be multiplied by climate change. So Calcium levels appear to be further decreased by forest fire frequency and drought, which are forecasted to continue to happen more and more with climate change. Climate change brings more storm events and warmer winter temperatures, which actually result in more salt use, which can further salt pollution of our surface waters. I don't know if you were watching last month's presentation, but Brendan mentioned that in one of their sample sites right near a highway, there was no benthic invertebrates or water bugs found in that sample. And though it wasn't necessarily proven, one could assume that salt was potentially one reason for there being no life in that area. A study by Pratt in 2020 indicated that warmer temperatures could substantially mineralize wetland and lake bottom organic matter, resulting in nutrients being released into the water column. So by mineralizing, think of it this way: when you warm something up, it mixes easily and more so. So when the water is warmed up, the soil underneath the water is also warmed up, releasing those chemicals and nutrients that were once held by the cooler sediment. So we'll have more nutrients getting into our water that was previously stored in the sediment, as well as toxic chemicals, including EDCs. Warmer temperatures and drought will also dry out our wetlands. So this results in habitat loss and the release of additional GAs into the atmosphere. So a good one to think about is specifically up north, where the peat bogs are drying and release as those warm up and dry out due to climate change. They're releasing more methane into the environment, which is a GHG, so the cycle just gets worse. Climate change in combination with the removal of terrestrial vegetation, so our trees and shrubs, etc., result in more wind and water caused erosion. And when our soil is exposed, the soil goes into the air, as well as it can just be washed into the water. And that soil is holding nutrients as well as different chemicals like EDCs and all different things, which are then made so we can breathe them, or made that they go into the water, and large amounts of sediment will cover up spawning areas and kill fish eggs. Climate change impacts aquatic food chains from both the top and the bottom. So many studies indicate that cold water fish species will be extirpated from much of their present range, with cool and warm water species expanding northward. What that means is we're going to lose a lot of the species that we know in this area. So like lake trout or whitefish, those are cold water species. Now, speaking of fish, why don't we talk about fish just quickly? Because I love fish. So these stressors that I've been talking about are cumulative and influence entire watersheds and the ecosystems within them. So the fish are at the top of the food chain, and they're an indicator of lake health. So they need to be studied. And like I said, I love fish. So let's make the connections between the stressors and fish. So obviously fish are affected by salt concentrations. They can't survive in a salty environment. Fish are 2 to 8% calcium. So when we decrease the calcium in the water, the fish cannot survive as well. EDCs bioaccumulate. So what that means is when fish eat smaller organisms that have the chemicals in them, the fish will have more. And that can cause feminization, cancers, and reproductive issues in fish. And this has specifically been noted in some minnow species. Also, excess nutrients coming from the soil and different sources will decrease oxygen concentrations, like I talked about, which lead to fish kills, which is when you see the fish floating belly up. Loss of shoreline vegetation removes shade and essential habitat. So fallen trees, you'd be surprised how essential they are for fish. So we need that shoreline vegetation. Also, loss of our shoreline vegetation causes erosion, which, like I talked about before, covers up fish eggs with sediment. Loss of wetlands limit essential habitat. For fish, many fish species use wetlands as nursery habitat. And like I also just talked about with the mineralization, with there's more toxins and nutrients get into the lake, which affect our fish population. Now, if you think about this, fish are an essential part of our economy. And in Eastern Canada, recreational fisheries supported a $3.39 billion industry. So here in Haliburton, recreation fishing is really important. So if we lost our fish, what would that mean for our communities? Now, I just want to go over this a little bit. So the MNRF was kind enough to share some recent data with me. This is from their broad scale monitoring program. And the data is not going back very far, so I can't really make any conclusions, which I think emphasizes the importance of monitoring and long-term monitoring. But one can make some guesses as to what's going on in these two lakes that I've shown here, Red Pine and Redstone, which are located in Haliburton County. So here you can see in these two lakes, when the lake trout populations are lower, where's my little, I lost my mouse, here we go. So here, so lake trout populations drop here and they drop here. We see increases in the rock bass and smallmouth bass populations. So first of all, lake trout like cold water, rock bass like warm water. Are our lakes warming up to favor these species? Furthermore, rock bass are not necessarily native. They're introduced to, I have the number here, they were introduced to 1,500 Ontario lakes in the past 30 years. So they're not a native species. And furthermore, rock bass eat lake trout eggs. So all these things combined we're going to see drops in our lake trout population. So how can you help? Well, you can note all the other previous suggestions. Like I said, fish are at the top of the food chain. So if you do everything else, you're helping fish. You can encourage the provincial government to fund and support fish monitoring. You can support fish research yourself. If you see MNR equipment out there, leave it alone. You can also report your catch on Fish Online. So the screen looks like this. If you just Google fish online and you can click on fish and then say what fish you caught in your lake, because that way it helps monitor which species are present. And maybe if we're not catching any more lake trout, then perhaps, for example, those lake trout are disappearing. I also suggest that you review the Guide to Eating Ontario Fish. And then if something is, something says you can't eat it, why can't you eat it? Learn about that and then figure out if there's something that you can do to help. Okay, so now that we've talked about things from the top and the bottom and everything in between that's stressing our lakes and making them ill, let's see if we can bring this science together. Let's make some connections. So some of these connections are scientifically proven and others are actually still just theories and are being studied. So lake stressors have many results, but two that we are familiar with and are very worrisome, like we talked about, are fish kills and algae blooms. So I will show you quickly how these stressors are related and result in those two things. So when we have climate change, it results in an increase in water temperatures, which decreases our fish population and increases our algae. Like we talked about before, salt is increasing, calcium is decreasing, therefore our Daphnia or water fleas are dying, our EDCs are increasing, as well as climate change. So these things all combined result in drop in fish populations. When our terrestrial vegetation is removed, our calcium drops and our sediment increases from erosion. So the roots are no longer holding the soil in place. So it washes into the water. And what that does is it brings nutrients and EDC, which then can make algae grow and kill our fish. And here, you kind of see what's going on here. It's a little bit of of a pattern where when we have decreased wetlands plus climate change, we'll have more nutrients and EDCs from mineralization getting into the water. We have our algae get more and our fish will die. And when we have less wetlands plus climate change, we also have more flooding. And flooding in turn results in more sediment and EDCs getting into the water again, which algae can grow and fish can die. So see, it's a little bit confusing. So making the connections and bringing the science together may be a little bit confusing. So maybe this can clear it up a little bit for you. Haha, just kidding. Not going to clear it up. The point is, lake health and watershed health is confusing. It's multifaceted, but this doesn't mean that you can't do anything about it. You have the power to help, and together we have the power to make a difference. So the fact is that we can no longer look at all these different stressors, whether it's calcium decline, wetland loss, added nutrients. We can't look at them in silos. Everything is important and everything is connected. So we need to work together to try to solve these problems. Now let's meet a couple of the people who are actually really working on this. So to put a face to the scientists, these are some of your local scientists that are doing research on all these topics. And we should be thankful for these people. They have a passion and they work hard. I strongly encourage you to continue your educational journey and look up these people and some of their papers they have written. And also you will be sent a resource list that can help you get started. And if you prefer watching rather than reading, on that resource list, I included a number of organizations that have digital recordings of presentations by some of these scientists that you can check out. So I talked about a lot of lake stressors, but I actually missed many more. So just if you're really interested in some of these things, you can look up loss of diversity, invasive species. All these things also impact the health of our lakes, as well as potentially increase our chance of algae blooms and fish kills. Here's some of my references. Don't worry about looking at those. Like I said, you'll be getting a reference list. And so lastly, I would just like to return back to a Thanksgiving address that I opened with, and that we, us here tonight and everybody else out there in the world, we may disagree on many things, but our minds can come together as one, and we can all agree that water is important to our lives. And of course, as David Attenborough said, self-interest is in the past and common interest is in the future. So our lakes and rivers are common interest. There are no property lines and no borders. So the future is us working together to preserve our fresh water. Thank you. Are you awake?
Thank you. Thank you, Katie. Thanks especially for drawing some connections between many of the presentations that have taken place at Enviro Cafes over the last few years, and trying to draw the connections between them. I mean, we tend sometimes to focus on aspects of it, narrower aspects of whether or not it's wetlands or blue-green algae, but often it's necessary to put these things together. And as you say, everything connects. So thank you for that presentation. I think it was very, very helpful. And I think it's going to help people make the connections between all sorts of things that appear to be distinct and disparate. So we're going to enter into or begin the question and comment and question and answer period. And I encourage you, I don't see very many things. There's a little bit of commentary going on with respect to salt, road salt, and so on. But I don't see anything specifically, a comment or a question being posed to Katie. But we're going to make a kind of a bridge to an overall question and answer period by focusing on what we're calling, by giving the floor to a couple of what we're calling first commenters. And so I want to introduce you to both of them. Carmen Piera and Liz Favat. Both of our first commentators are going to pose a comment and then ask a question of Katie. And after that, what I'll do is I'll just simply go into the chat function and pose questions to whoever the question is put to, principally probably Katie, but also offer the opportunity to Cameron and to Liz to comment if they want to. So a little bit of background. Carmen is currently completing a PhD at Queen's University in Kingston. Her primary focus is studying the long-term changes of algae in lakes and the Precambrian shield and understanding why those changes are occurring. In addition, she's part of the consulting firm that she and Katie and one other partner have created recently. Carmen, are you ready to?
Yep, I'm ready.
Okay, I'll
Okay.
leave the introduction to Liz until I actually call on her to put the comment and put the question to Katie. So the floor is yours.
Okay. Thanks, Katie, for not only tying a lot of connections together about what's happening in our lakes and the stressors, but providing some solutions. And one of the solutions that I was interested in was you talked about having buffered vegetated strips. So my question is how long and wide do vegetated strips need to be? How far from the shoreline? And what is the best type of vegetation to be an effective buffer to keep these stressors from impacting our lakes?
Thanks, Carmen. That's a great question. So I guess maybe to start that is how did this idea of buffer strips and things start? So from what I understand from the literature is actually in the 1960s and 70s in the southern states and different parts of the world with agriculture, they were noticing algae blooms because of high nutrients being applied to fields. So scientists started looking at, well, what happens if we plant some different vegetation along the water and make a buffer between the field and the fresh and the surface water? So obviously what they found is that when they planted vegetation, and the bigger the vegetation is, for example, trees versus grass, the more effective it was at stopping the sediment and things from going into the water. So in Ontario, we see some similar work and things being done specifically in regards to forestry and the government having some things put in place to protect waterways from forestry so that there's not clear cuts done right to the water's edge. Most recently, what we actually see though is cumulative studies or landscape policies and landscape studies. So what this means is that what they're finding is the more vegetation, the better. The more vegetation in an entire watershed, the better. So when you want to know how wide is an ideal buffer strip, the correct answer is as wide as possible. Like we talked about before with the Schindler and Shear 2002 report, they were saying everything is connected. Our groundwater, our ponds, our wetlands, our lakes, everything is connected. So even if you don't live on the water, you by planting native vegetation is having a positive impact on your watershed as you're impacting the groundwater, which is connected to the surface water. So yeah, just the more vegetation, the better. In regards to what type of vegetation, native vegetation. If you're coming into a site that has been denuded like you have a big lawn or something like that, and there's no vegetation there, what you can do is look to adjacent areas, see what's growing well, and that's what will probably grow well in your area. You can also look at your soil and figure out which plants grow best in your soil, etc. To me, that's a bit confusing. I would just be like, there's some pine trees, I'll plant some pine trees. Just kind of keep it easy. It doesn't need to be complicated. And, just remember that nature knows best. So whatever's natural, and that's what's going to do the best job. And vegetation, it helps all of these stressors. It helps reduce the impacts of climate change. It adds calcium to our lakes and soil. It mitigates and slows down salt from getting into our waterways. It just helps everything.
Okay, well, thank you for that, Carmen. And I'm going to turn now to Liz Favat. Liz was a recent Enviro Cafe presenter on blue-green algae. Many of you may have joined us at that Enviro Cafe. And she recently received her PhD on that topic from Queen's University. Liz is currently employed by FOCA and in the joint project that they've got going with the Lake Partner Program with the Ministry of the Environment, Conservation and Parks. And that Liz is currently employed at the Dorset Environmental Science Center just north of here. So Liz, I take it you have a comment and a question you want to put to Katie.
Yeah, I do. Thanks for having me again to Enviro Cafe. It's been a really great winter of talks. I've been able to make a few of them. And Katie, thank you for a really great overview of how a multitude of environmental stressors are impacting our lakes. I completely agree with you that like often I think just by necessity, some of these stressors are kind of siloed, but they definitely interact with each other. So it was nice to see kind of an overview and for you to emphasize how they're all connected. So despite that, I'm kind of wondering what you think are the most impactful kind of first steps that lake users can take to start mitigating some of these stressors.
Right, so that's a good question and a hard one
Yeah.
because there's so many things people could be doing. But I think if you are a lake user, so whether you live on the lake or you are just a frequent boater or swimmer, the first thing that I would recommend you do is that you explore your lake. Get to know it physically. Get out there, find the inflow flows, find the little secret areas. If you can, learn the history of the lake, the human history. Who was there before you? How big did the fish used to be? If we make that emotional connection to our environment, we're more likely to attempt to preserve it and study it and protect it. So I would say just getting to know your waterway. And then once you've done that, then you're like, oh yeah, this place is awesome. And then you might participate in monitoring. And then you're, oh my gosh, something's changing. And you become more and more involved. And then you're likely to take action. If you don't have that emotional connection and users don't have that emotional connection to their waterways, they might be like, I'll just dump some garbage in here. That doesn't affect me. But once they learn how they're connected to it, then they're more likely to act. And saying that, whether that action is putting their ash on their forest or making sure they wash their boats before they enter a new lake so they're not spreading invasive species. Maybe it's being involved in the lake partner program or planting some trees. All of those things I think are important. And I wouldn't say that there's one specific thing that a lake user should be doing. If they should find what they're interested in. So once they love their lake, then, figure out what interests you and focus on that. And then share your knowledge. So, if you're a part of a lake association, you could organize an event to encourage your other lake users to explore the lake, whether that's a canoe trip or a scavenger hunt or something like that, to get them to love the lake too. And then eventually everybody will hopefully be doing more to decrease these stressors.
Well, thank you for that question, Liz, and thank you, Katie, for the answer. I was just going to reiterate, and someone has done so, I think it's Bob Carter in the chat room, about emphasizing the importance of connecting with lake associations. And just on a personal note, one of the first things I did when I became associated with the family that owned a cottage in Haliburton was join the local lake association, and it was developing a lake plan at that point, which is one of the best ways to get at what you were talking about, Katie. The history of the lake, something about how development took place, and so on and so forth. And it's a good forum for being able to get together with others to talk about the good, the bad, and the ugly that's going on around your lake, and share stories and history about that. So lake associations are incredibly important sources of personal connection and sources of information. Terry Reese from FOCA has put a comment that echoes what you said, Katie, about invasive species, and he's put a link to a comment period which is currently going on with respect to a proposal that would limit the discharge of invasive species into our water courses. I'm not sure exactly what this proposal is, but it also apparently has something to do with the movement of watercraft over land to other bodies and limiting things like, I would imagine, releasing, the bilge water and so on into other water bodies. And so there's a connection that Terry has put into the chat function where people can put their comments on that site. So I encourage people to do that. Now there is a comment it's a question actually about logging. And someone has put in there that they have a logging company clearing trees around our lake. And they're asking, what would the impact of that be on our lake? Katie, want to take that?
Well, I don't. It's hard to say what the direct immediate effects would be. I'm assuming that they would be doing, the best management logging practices. But from a long-term perspective, yes, they're removing the trees, which in turn removes the calcium and other nutrients and minerals that would originally be in that forest. So those are being removed. If the tree removal is excessive, it will obviously cause soil erosion. And near, there's often little streams and things like that, at which point the soil could potentially erode into those. And then that would make its way into the water. Now, if the forestry company is doing the best management practices, that should mitigate the soil erosion problem. But if there are any concerns that they might have, they can, if it's Crown land, they can ask the Ministry of Natural Resources and Forestry for some information about that. But yeah, it's hard to say what the immediate effects would be. But it'll also be, loss of habitat for those wildlife species that might depend on some of those trees.
Yeah, just on that, we happen to have some property on our lake that is surrounded by Crown land, and there has been recent significant logging activity on that Crown land with a lot of development of logging roads and landing areas. And I think that it's really important that people think about this and pay attention to it. So if you've got a forested area that you care about and you want to know what's going on around you and that you think might have an impact on the water course, I encourage you to ask questions about this. If it's on Crown land, chances are it'd be the Minden Bancroft Forestry Company in this neck of the woods, and they're required to file forest management plans. And you can engage in a critical but reasonable, civilized conversation with them if you have differences and you want to know what they're up to and why, and whether or not the local contractor is actually engaged in best management practices or not. And I encourage you to really get into and get literate with respect to the rules of forestry on both private and Crown forests in this neck of the woods. So we have a question about beavers. Now I think I missed a question. I'll come back to it, but someone is putting in the chat function a question of do they have a positive or negative effect on the health of the shoreline, and should we kill them?
That's a good question, and it's when I used to work for Ministry of Natural Resources and Forestry, that was questions I got all the time. How do we manage the beavers? We have to remember that beavers are native to the land and we are not. In saying that, they can cause a lot of property damage. Just down the road from me, actually, they've removed a swath of trees very quickly. But remember, when the beavers are doing that, they are leaving the roots. So they're, like I said, they're a natural animal. So, and they're often removing pioneer species that will regrow, like poplars and alders and those kinds of things are beavers' favorites. So should you be killing the beavers? I would say no, unless they're causing you specifically major property damage. At which case you need to go about it the right way. It is illegal to kill them unless you're a licensed trapper. So there are different things you can do to deter beavers. For example, you can put some metal things like around your trees, fencing. Yeah, someone's saying here, wrap chicken wire around your tree bases. that, that works great. And sometimes you might have to use multiple layers because those teeth are pretty strong. Yeah, and just and go from there. There's different things you can deter the beaver, and they do prefer, like I said, the trembling aspen and the poplar species. So you might be better off to plant some coniferous species along your shoreline to help deter the beavers.
So I noticed that Leora Berman from the Land Between has put a comment in there as well, as beavers are responsible for 84% of the water in the highlands. Without them, we would not have wetlands. They feed on poplars and roots, and these plants grow more stronger as a result of beaver activities typically. So I think that before we start doing in other species, we certainly, first off, recognize that they obviously have a right to live. They're native to this land, and we should only do something that would harm them when it's absolutely necessary. And I think that respect, what they do in terms of the positive changes they bring to the landscape in this neck of the woods. There was a comment, there was a question in here about an article, I guess, that appeared in the Highlander recently about an oil spill along the Drag River Basin that had been going on apparently for about 11 years. It may take, it's under investigation now. And the question is, does it make it worse to disturb an empty tank or a tank that's, I guess, in the process of emptying itself, or leave it there? And it said it can be seen along the waterfall next to Emerson's and at times under the bridge at Head Lake. So she wants you to comment on the ongoing leak of that oil into the Drag River.
Well, Carmen or Liz, do you have any comments about the chemistry aspect of the oil going into the water?
I don't really. I think you'd have to ask an expert about that, about contaminated sites, about how to deal with that.
Yeah, I mean, of course, like if it's a slow leakage, it's going to disturb the natural chemistry and balance, and anything that disrupts the balance of what is naturally there could have impacts. This is when we see changes in the ecosystem, which could cause things like algal blooms. Algal blooms and stuff like that happen because of some kind of ecological imbalance. So that's the only thing that I could think is a potential outcome of this slow leak. So I would be concerned about. And then of course it is oil. You've got some organic contaminants in there that can act as EDCs as well. But I mean, really, what could happen is unknown. It's just probably not going to be good. It is going to have a disturbance in the balance of that ecosystem.
It's probably something that should be called into the Spills Action Center if it hasn't already.
Well, it appears that it's been under investigation, and it's talking about, the person's talking about some kind of a 5-year time period before this is going to be resolved. I'm not sure what that means, but I take it that the Ministry of the Environment, Conservation and Parks does have a spills action team, and they are typically called out in these circumstances, and they have the capacity to respond faster than 5 years. So my sense is that they should and could be doing an assessment, a risk assessment of what's going on there, and determine whether or not more robust intervention is required in the short term, rather than taking a long period to assess whether or not it's better or not to intervene. So I would encourage someone, if you're concerned about this, is to call the spills hotline for the Ministry of the Environment and try to have a conversation going with people on the other end of the line about what exactly is going on here and why. There's another question here about many roads being very close to shorelines, and asking about whether or not those roads can be moved away. Well, I can imagine there's a couple of municipal councillors on this meeting, and I would imagine their eyes would roll with respect to the issues associated with moving roads. But does anybody want to comment on that? About, if we got a problem, I take it that would be all sorts of contaminants can end up in the water because of the proximity of roads to the shoreline. Obviously, the roads themselves, when you put them in, they eliminate significant portions of the natural shoreline. And I'm cognizant of what you said, Katie, earlier about the benthics that were reflected around a lake where there was a highway coming very close to the shoreline of that road, probably being the source of road salt contamination that's really doing a lot of damage to the life on the shoreline. So does anybody want to comment though about the issue of moving roads? No brave souls here?
I don't know how anything much about moving roads, but I mean, the research is out there. Liz and I have a colleague, Robin, who has studied Jevons Lake. That's close to Gravenhurst, that's really close to the road. And we've seen the amount of chloride in that. It's exponential. Well, it's much higher than other lakes that aren't as close to roads. So the research is out there. And Terry, before we've started this presentation, you mentioned good science leads to good policy. So thankfully we have people within our research groups with Liz and I in our group that are looking at the impacts of roads being close to lakes. So hopefully eventually down the road something can happen, but I don't know anything that's happening in the near future.
Okay, with respect to the spills reporting, I just want to go back to that for a second. Terry Reese has posted something in the chat line about the link to the Spills Action Center that the Ministry of the Environment maintains. So that's been listed in the chat function. If you want to, you can, anybody can copy and save that chat to your computer. And so if you want to keep that that reference that Terry has posted. So let me just see what, and I also, John Smith has posted the 1-800 number, I think. Oh, no, he said that it has, but that Terry has got the 1-800 number. Okay, so there is a question here about water being, pesticide being sprayed close to a water course for purposes of killing or controlling mosquitoes. And there's a comment to the effect that those pesticides kill bees and aquatic life, and companies are advertising on billboards, around the county to eliminate mosquitoes. Yeah, I've seen a lot of those signs myself. Does anybody want to comment on the impact that kind of herbicide or pesticide spraying can have on water quality? Anybody?
I guess I could go first. So a lot of these chemicals that they're advertising now, they say they're safe for people and pets. But I think, I can't remember when exactly this was, but we did have a presentation by Eco Pest Control out of Halliburton. And, they were saying if you're looking to minimize mosquitoes on your property, what you can do is try to minimize your moisture. So trim your vegetation so the ground can dry out, and rake up your leaves, because the mosquitoes will harbor in that moisture under the leaves. So if you dry out your ground, you're naturally going to remove some of your mosquitoes in your immediate area. And yes, even the eco-friendly products such as like the garlic spray and things like that do kill everything else as well, not just mosquitoes or black flies. And so you definitely should not be, I don't spray anything at all, and I would recommend not spraying anything if you can avoid it, and just figuring out ways that you can mitigate your property to live with the mosquitoes. For example, have your deck elevated, dry out your immediate vegetation. And yes, those chemicals can impact aquatic environments. I'm not sure exactly the chemistry and the biology behind it. But girls, do you want to add anything else?
I would add something. I'm the person that put the question up, and I did do some research. I did call Mosquito Buzz, and they told me that they are not allowed to spray within 15 feet of any body, 15 meters of any body of water. I looked at the government website, and they talked about a 10-meter barrier, and they're not to spray in a high wind because it can drift. They're not to spray on any banks that go down towards the water, because when it dries and it's on the soil, it will wash into the water and destroy the water, or can kill aquatic life in the water. And we had a company last year come by our lake, just for information. And that particular company, not the one I just mentioned, sprayed actually over the body of water into the trees that were hanging over the body of water. And that's an absolute no-no. So it's important, if anybody wants to spray, they have to know what these companies can and cannot do. Because the government's pretty strict about the rules regarding it. And besides that, just for your information, these are also sprayed on a lot of the vegetables that we buy in the stores, and they have all their rules regarding large crops. So I just think it's something that we have to become aware of up here, because of the fact that the business is invading our area, and we want to protect our bodies of water. That's my 2 cents.
So just for people's information, if you take a look at the chat box, there's been a number of useful comments put in the chat box with respect to insects, natural controls of insects, what bird populations are doing to control them, what dragonflies do to control them, you know, and so on. So it's useful, and including a comment that one way to actually protect ourselves rather than engaging companies like this to spray pesticides is to wear bug suits and bug hats, and to, you know, to do what we've always done to try to protect ourselves from mosquitoes, but to recognize at the same time they perform a useful biological function in the ecosystem, and many other you know, life forms, you know, use them as food, and they're part of the food chain. So you know, just treating them as enemies or public enemy number one is something that we should think carefully about. I think that there's one more question that we got. We got time for one more. We're just at 9 o'clock, and we typically want to sign off at 9 o'clock. There's a question with respect to whether or not pressure treated docks affect lake water quality.
That's a good question. And yes, so pressure treated wood is not as toxic as it used to be. I think, Terry, you once did a Planet Halliburton on pressure treated wood, but in saying that, there are still chemicals in it. We always recommend that if you building a dock, that you use natural wood like cedar or hemlock, as it has natural tannins that will protect the wood and make it last longer, versus pressure treated wood. Even though it's not as toxic as it used to be, it's still recommended that you don't come in contact for long periods of time with pressure treated wood on your bare skin, or cut large quantities of it, because of the it can get in the air and then get into your lungs, and could be very harmful. So in regards to the chemicals getting into the water, I'll let Carmen or Liz talk about that a little bit more.
I've thought about the chemicals in pressure treated wood, but never in a dock before. But almost certainly, like, if you're not supposed to touch the dock, it's definitely going into the water. But I don't know what the specific impacts would be of those chemicals.
Carmen, you want in on that, or you going to leave it there?
I think what Katie and Liz said were pretty accurate. Yeah.
Okay. All right. So I'm going to basically call this portion of the meeting to an end. I would encourage people to take a look at the comments in the chat function, save it for future reference. If you want to go back to any of the things that have been offered, the suggestions and so on, we'll be saving it. And I also encourage you to take a look at the resource list that Katie has put together. It is quite a remarkable list, and it's going to be sent out automatically, as they say, to everybody who registered for tonight's Enviro Cafe, and that'll be done as soon as possible. I'm going to end things there for me and turn things back to Susan, but I want to thank all of the people I want to thank Carmen and Liz, but most of all, I want to thank Katie for your excellent presentation. And I want to thank everybody else for taking the time and effort to join us tonight to have a conversation about these really important issues.